All right, so now let's talk about dimensional analysis. Kids, we struggle with this, right? Because we've hardly done any dimensional analysis in physics so far. But let's just do it because why not? Dimensional analysis is a quick way to check whether you've done the correct mathematics. So let's just do it for example. Okay, let's imagine that we know that the force, the Coulombic force, is K Q over R squared. Okay, let's suppose we solve that for R. R is going to be, what is it going to be? It's going to be the square root of, is it K Q over F? I think it is, right? I did a little math. I put that guy down there, put this up here. I did the square root, but I did it so quickly that I want to check the units, okay? So what we do is we plug in our units, right? Now, if you recall, the K has the values of Newton meters squared per Coulomb squared. That's what K is, right? Okay, and then this is coulombs and coulombs, right? So we've got coulombs and coulombs, right? And then the denominator is newtons, and it's the square root of that. Now, if I made a mistake, it's possible that these units won't come out to be meters, right? This is a radius in meters. And so let's just do a little canceling here, right? The coulombs cancels that, and that coulomb gets rid of that one. Newtons goes the way of the free zone in downtown Portland. That was obscure. Okay, and then we end up with the square root of meters squared, right? And so I believe that's meters, right? So that would be an example of dimensional analysis. Okay. Now what you're going to do is I've picked the units you should put in. These units are kind of crazy. Some of them are a little bit crazy, right? Newtons are made out of weird things. So what I did was I gave you things to plug in, right? So for rho, here's rho. Once you get remember, you're going to solve that for Q. You're going to have Q equals something big and ugly, okay? Big old thing there. But wherever you find rho, don't put the symbol for it. Write another expression where you replace the rho with kilograms per cubic meter, because that's what density is, right? Wherever R is, right, whatever power it's raised to, you're going to put M in there and raise it to the same power, right? Wherever you see G, replace the G with newtons per kilogram. Okay, wherever you see the voltage, it's joules per coulomb, right? But I made it Newton meters per coulomb. This is a real help, right? Ultimately, we'd have to bust this down into like kilograms and meters and seconds and stuff like that. I'm just trying to make it easier for you. Wherever you see, the answer should come out in coulombs, right? Okay, and then wherever you see the D, substitute the symbol for the D for M, okay? So take this expression that you have when you solved it algebraically for Q, that is, you multiply by D divided by the voltage, right? In that expression, substitute the symbols, substitute the units for them. If it's raised to the third power, raise the units to the third power. Cancel the units. Hopefully you'll end up with coulombs. Coulombs equals coulombs. The world is a good place. That's dimensional analysis, okay?